Okay, so just as if we were meeting in real life over Zoom, I'm going to start off class today by answering your questions that you submitted in your 321s Tuesday night. And I have once again divided these into class questions and content questions, and I have them on my phone so I don't forget. So, class questions. Are the tests open book? Am I allowed to use the textbook and notes? Yeah, all of my tests are open book because I don't really care. In order to answer the questions, you will need to be able to show understanding. I don't ask, yes, they're open book. Are we going to be tested heavily on the sciencey stuff? No, the sciencey stuff is done after this video because this video is all sciencey stuff based on the questions that you asked. But after that, no more sciencey stuff, I promise. For the homework, is there a specific word count that you are looking for in assignments to meet the criteria? No. You need to answer the question in full. And I always set up my questions so that there are multiple parts, and I try to signpost them. So that's why it says, give 2 examples of, be sure to explain which of, that kind of thing. As long as you answer the question in full, you should get full points unless you completely got the answer wrong. But yeah, just answer the question in full. There's no word count required. Would you like for us to provide quotes from the book? You can if you want, if it helps you. Be sure to cite your sources. But no, you are not required to give quotes, just like there is no required word count. I want you to be making an argument. I want you to come up with a position to answer the question fully, and support your answer. Does it matter what edition of the textbook we find? No. You can use whatever edition you want to use. Just remember that if you are using an edition other than the 2nd edition, the page numbers might be slightly off. But that's why for the most part I said, okay, read chapter 2, read chapter 3. I tried to avoid page numbers as much as possible, specifically to allow you to use other editions of the book. Why is class not being recorded? I know you answered this, but my computer was being silly. Yeah, so class isn't recorded because you have to attend class. If you don't, that's the whole point of this being a synchronous thing. Classes in normal times are not recorded, and I'm not recording classes now for the same reason. You have to show up and participate in order to get the full benefit. You aren't going to get the full benefit of the lecture just by logging in later on and watching what other people said. It's a participatory educational experience. An experiment. Sometimes I experiment. So that's it for the class questions, and then we're going to move into the content questions. So warning, lots of sciencey bits ahead. What makes certain disorders genetic? So a disorder is genetic if the origin of that disorder can be found, is somehow heritable. So it can be passed down from one person to another person, or if it is the result of a mutation or a change or something happening in your genetic makeup. So that could be your DNA, that can be genes, that can be chromosomes. All 3 are options. If the source of your condition is in one of those 3, then it is considered a genetic disorder. What are some more types of mutations that can occur from genetic abnormalities? And yeah, so remember there are 3 types of mutations. There are substitutions, deletions, and additions. A substitution is where a piece of DNA gets substituted for another piece of DNA and they accidentally get switched. An example of this is sickle cell anemia. So we learned that sickle cell anemia is an inherited genetic disease. So and it's recessive. So on the 11th chromosome, at one point there was a mutation. And that mutation in the gene causes sickle cell anemia. That mutation is carried by one person, and they go through the parents. So if both parents have that mutation, then their child can have sickle cell anemia because it's recessive. So in order to have it, you need to have 2 recessive 2 copies of the gene because it's recessive, it's not dominant. If it was dominant, you would only need 1 copy of the gene. So that's important. But yeah, so if both parents have a copy of the mutated gene causing sickle cell anemia and you inherit both copies, then you will have it. But originally it was a mutation on the 11th chromosome. A deletion is where a piece of DNA just went poof. It went off into the ether. It decided not to no longer exist. It's very annoying. An example of this is cystic fibrosis. So again, this is a recessive inherited disease usually. However, it was originally a mutation and it's recessive. So both parents have to have a copy of the mutated gene and you have to inherit copies from both of your parents in order to have cystic fibrosis. If you only inherit 1 copy, you will be a carrier, but you will not have it yourself. Yes. And that is but originally this was a mutation on the 7th chromosome. And then finally, an addition type mutation is called beta thalassemia. So this is a blood disorder, and again, like sickle cell anemia, this is a mutation that is found on the 11th chromosome. It impacts your red blood cell production, how many red blood cells you produce. I can say that. And it's found on the 11th chromosome. Again, it becomes inherited and it's recessive, so you need copies from both of your parents, but it is considered a mutation of the 7th chromosome that becomes inherited, just like my father has a random mutation in his hair and I inherited it from him. So all of these mutations become part of your genetic code and you can pass them on to your children. Next question. With the new technology available, like genetic engineering and DNA splicing, would it be possible to phase out most genetic diseases, especially the ones that are dominant? No, because a lot of genetic diseases, so what I was just talking about, those 3, they're called point mutations, and it's because there's only 1 point in your genome that is causing this disorder. Most genetic diseases are not single point mutations. They are normally multiple genes that are involved, and it becomes very complicated. So if it was something as simple as splicing 1 gene or splicing 1 tiny segment of DNA, that might be easier to do. But most genetic disorders are not that simple, and many different genes and on different chromosomes are involved, so it gets very complicated and there's no real way to do it at this point. There's also the ethics question of whether or not it is okay to change a person's DNA, what makes them at a point where they cannot give consent to that, because these are babies. So they can't give consent to having their genotype changed. Would you be okay with having your DNA changed? It's a little hairy in the ethics department. Can you develop a mutation as you get older in age? Mostly no. So the way we're talking about mutations here, in terms of this is something that affects your entire body, every single cell, every single copy of your DNA has this exact same thing. No, that your DNA code, your genome is not going to change after conception. That it's there. However, single cells can mutate, and when they do, you get cancer. So a lot of the most common mutation in cells is replication mutation. So how often should I replicate? And that's how tumors evolve, is there's a faulty mutation in one cell that is saying, oh, I need to replicate, and it gets bigger and bigger and bigger and bigger. And that's a tumor, and that is cancer. How is it that some parents can both have dark hair, yet their child has blonde hair? So this is the difference between dominant and recessive genes, and it gets into Punnett squares. So I'm going to read the next question as well, which was, who invented Punnett squares and how did they know it was correct? So I had to look it up. His name was Reginald Crundle Punnett. He was an early geneticist. He's the one that invented Punnett squares. And a Punnett square is a way of calculating probabilities. That's basically all it is. It only works for true recessive dominant pairings. It does not work for partially dominant. So, my little Punnett square. You see how, and we're going to do it for blonde and black hair. So in this case, blonde is the little b and black is the big B. When you see this, we're going to assume that the parents are both heterozygous, meaning that they have one copy of the little b and one copy of the big B. They both have black hair because big B is dominant. So they're going to have black hair. However, if you look at the Punnett square, you have two big B's. You have one big B. So you have one child with two big B's. You have one child with two little b's. And you have two children with one big B and one little b. Voila. So the child that got the two recessive genes, the two little b's, will be blonde, even though all of the other people in their family have black hair. I hope that helps. Is an allele the result of two genes merging? No. So a gene refers to a very specific point on a chromosome. Remember that we have 46 chromosomes arranged in 23 pairs. A gene is one spot on that chromosome. I'll put up another little chart for you. An allele is a variant of a gene. So it can be the gene dictating how much pain, pain receptors, what your pain level is. You can have, it's all the same gene, but the alleles, the differences in change, is what dictates how much pain you can take as a person before dissolving into a puddle on the floor. The official definition of an allele is, an allele is a variant form of a given gene, meaning it is one of two or more versions of a known mutation at the same place on a chromosome. So genes are arranged on chromosomes. An allele is a variation of a gene. When they say mutation, they don't mean mutation like we were talking up above. We're talking variations in genes. This is natural genetic change. Mutations are natural too, but you know what I mean. Okay, now, what causes chromosomal abnormalities? So chromosomal abnormalities meaning an extra chromosome, a missing chromosome, a bit of a missing chromosome. These are results of mistakes, I guess, errors in mitosis and meiosis. So, and meiosis is more prone to these because it has remember it has 8 phases instead of the mitosis is 4 phases, and there's the recombination bit where the genes splice and rearrange themselves. So you can accidentally end up in meiosis with a haploid cell, which is only supposed to have one X chromosome, with 2 X chromosomes. Or you can end up with an extra 21st chromosome. So remember, this haploid cell, we'll say it's the ovum, accidentally only has 2 21st chromosomes. So it has both of them. Then when the sperm comes in and it has a single copy of the 21st chromosome, now this cell, this single conceived cell, has 3 21st chromosomes. So this is called trisomy 21. That is what causes Down syndrome. You have 3 copies of the 21st chromosome. That was a result of an error in meiosis. Okay, does Klinefelter syndrome mean that males are technically both male and female? No. It is considered an intersex condition, but it doesn't necessarily mean that they are both male and female. They will be generally assigned a sex at birth based upon the appearance of their external genitalia. This goes for pretty much all sex chromosome-based conditions. So no, they're generally considered one or the other, and it's based, if they have ambiguous external genitalia, they will be considered intersex, not both. And then there was a second part of this question. From the reading, that's how I'm interpreting it. In addition, are men more susceptible to genetic predispositions as opposed to women? Generally, no. They are more predisposed to genetic conditions that are found on the X chromosome because, remember, 46 chromosomes and 23 pairs. The 23rd pair is X, is your gender marker, so it's XX or XY normally. Women are XX, men are XY. If there is a genetic disorder that is found on the X chromosome, and remember most genetic disorders are recessive, meaning you need 2 copies of the same gene, of the same faulty gene in order to actually have that condition. If it's an X chromosome based disorder, there's no corrective. So a woman won't get it. If you have an X chromosome from your father who's a carrier and an X chromosome from your mother who is not a carrier, then when you get down and you are conceived, because your mother who is not a carrier did not have that faulty gene she is going to be dominant, you will not have it. However, if you were a boy and it's X and Y, and so the gene is faulty on the X side and you don't have a second X chromosome to fix that, then you are going to have that genetic disorder. So males are more prone to X chromosome based genetic disorders. Please provide a deeper understanding on gene-environment correlation and how the role of the process is important to the developmental aspect. So a gene-environment correlation is how much a heritable trait is impacted by the environment and how it is impacted by the environment. So in the textbook, it talks about passive and active gene environment correlations. There's actually 3. There's actually passive, evocative, and active gene environment correlations. I'm going to read you the official rules, and then I'm going to explain it. So, a passive gene environment correlation refers to the association when the genotype a child inherits from her parents and the environment in which the child is raised. So parents tend to create a home environment that is comfortable for their heritable traits. And because of that, it is also comfortable for their child's heritable traits. So they are creating an environment that naturally encourages their child's heritable traits because those are the traits they got from their parents, and their parents are creating an environment that is comfortable for them. Thus, because the child is not doing anything special, they are said to have a passive genetic environment correlation because they're not changing anything. Then we have an evocative gene environment correlation, which happens when an individual's heritable behavior evokes an environmental response. So the child's inherited trait causes, and their expression of that inherited trait causes the environment to change, to adapt to their needs. And then we have active gene environment correlation, which occurs when an individual possesses a heritable inclination to select environmental exposure. So this is where a child seeks out opportunities based on their inherited traits. Let me illustrate this with the idea of a little girl who likes to sing. Maybe we'll call her Peggy. So, Peggy has an inherited predisposition for a talent for singing. In a passive gene environment correlation situation, she is in a family full of singers. Everybody is always singing in her house. So she is naturally encouraged to sing because that is what her environment expects of her. So then she gets this practice opportunity and she becomes better and better over time. In an evocative gene environment correlation type situation, Peggy's mother, who does not sing, notices that Peggy is a really good singer and signs her up for singing lessons, thus changing the environment in which Peggy is living and giving her an opportunity to practice singing. She changed the environment, but she did not actually seek out new opportunities herself. She simply caused a reaction in her environment. She caused her mother to change the environment for her. And finally, we have the active gene environment correlation. In this case, Peggy loves to sing, so she goes out and she joins a choir. She seeks out opportunities to sing and to practice and to become better and better. I hope that was helpful. And that was the last question. So, well done. Don't forget to do your 3, 2, 1s after reviewing all of the rest of the slides, and I will see you next Tuesday.